Dear friends, welcome to a lecture on complex analysis. In this lecture, we shall study roots of complex numbers. We earlier have seen that a complex number can be written in the form of in exponential form as z is equal to r e power I theta, where r is modulus of this complex number and theta is argument. Or we can represent this complex number as a circle having center at origin and whose radius is r. And see, this r into e power I theta is the number here expressed as z, r e power I theta. This vector is r and this angle is theta. Now we know that if this angle is increased or decreased by multiple of 2 pi, we get the same position, and therefore this complex number r will be complex number z will be written as r into e power I theta plus 2k pi, where k takes values 0, plus minus 1, plus minus 2, etc. And thus the two complex numbers, or in general, if we have z1 is equal to r1 e power I theta 1 and z2 is equal to r2 e power I theta 2, then z1 is equal to z2 if and only if r1 is equal to r2, positive numbers, and this theta 1 is equal to, may not be exactly equal to theta 2, but theta 2 plus 2k pi, where k takes value 0, plus minus 1, etc., plus minus 2 and so on. So that is this expression is written in this form. The two complex numbers are equal if this absolute value must be the same, and this angle theta may differ by multiple of integer multiple of 2 pi. And using this, suppose we want to find nth root of z naught. Let z naught be equal to r naught e power I theta naught. And this z naught is again written in the form of, this is equal to z naught is r naught e power I theta naught plus 2k pi, as like this. This theta is, it can be replaced by theta plus 2k pi, because if you add 2 pi to this angle here, then we get the same position as this one. This is theta plus 2k pi, 2k, theta plus 2 pi, and so on. So now we want to take the, we want to find nth root of z naught. Then nth root of z naught is given by z naught power 1 by n. To get nth root means we have to raise the power by 1 by n, and this is taking 1 by n power on either side, we get r naught raised to 1 by n, and the power of this raised to 1 by n means this is divided by n. So e power I theta naught plus 2k pi divided by n, or which may also be written as a exponential of this, or this is nth root of r naught, nth root of r naught, and another notation for this is exponential of I into bracket, and this we may write as theta naught divided by n plus 2k pi divided by n. Here n is taking values, and we should have to write here k is 0, plus minus 1, plus minus 2, etc. And here nth root, n is equal to 2, 3 and so on, positive root. and thus here this is nth root, z naught raised to 1 by n. This gives nth root of this. N is equal to 2, 3 and so on, and k is 0, plus minus 1, plus minus 2, plus minus 3 and so on. But here k, we have written k can take infinitely many values, but nth root of z naught will have exactly distinct n values, and that distinct n values are given by n values of k starting with 0. So, the distinct n roots distinct values of n roots are denoted by, this is the notation we shall use, C naught, C1, C2 and so on, Ck, etc. And that is these values are exactly k is equal to n, where Ck is equal to, putting k is here, and that is nth root of r naught exponential of I into bracket theta naught divided by n plus 2k pi divided by n, and here k takes values 0, 1, 2 up to n minus 1 Ck. These are the values where Ck is this nth root of r naught. This is positive value, positive root of nth root of r naught, and exponential I into bracket theta naught divided by n plus 2k pi divided by n, where k takes these values. So, this we have to remember, and these nth roots will lie on the vertices of a regular polygon inscribed, polygon of n sides. These roots, these n roots, when n is greater than or equal to 3, will lie at the vertices of a regular polygon of side n inscribed in the circle with center at the origin and radius n root of r naught. So, that means these roots will lie on a polygon. The polygon may be the polygon is inscribed in this circle of radius of this circle is nth root of r naught, and the roots differ by an angle 2 pi divided by n. If Ck minus 1 is one root, then another root is Ck will be here, and the angle will differ by 2 pi by n. So, that is the meaning. So, if there are n roots, then these are equally spaced and if we join the vertices, we will get a regular polygon of side n. Now we shall consider nth root of unity. Nth roots of unity. That means we want to find out 1 power 1 by n, nth root of unity. We have, first we shall express 1. 1 is equal to 1 into e power I into 0, and this is again written as 1 is equal to 1 e power I 0 plus 2k pi. K takes values 0 plus minus 1 plus minus 2 etc. in general first, and to get the distinct root we will take the values of k as n values starting with 0. Other roots will be repeated roots, and therefore here we shall consider the now nth root of unity, taking 1 by nth power on either side. We get 1 to the power 1 by n, and 1 to the power 1 by n again here is, this is positive value, and therefore we will get this value as 1, and e power I into bracket 0, or that the 0 plus 2k pi is 2k pi divided by n, or this is, that is 1 to the power 1 by n. Actually there is no need to write this 1, but we have written because this is 1, therefore the modulus is 1 and it is positive value. So here we have to take, this is modulus of the complex number, and therefore its value is positive, and so positive value means we have to take the nth root of positive nth root of 1 as 1, and therefore this is exponential of e power I 2k pi by n, and in the trigonometric form this will be cos 2k pi divided by n plus I sin 2k pi divided by n. So this is the expression, and here k gives the values 0, 1, 2, 3 up to n minus 1. So we shall suppose this as 1, and now we will get different roots. We have expressed it in the same form. So square roots of unity. To get square root means n is equal to 2. So put n is equal to 2 in this expression. Putting n is equal to 2, we get in 1, and at the same time we shall put k is equal to 0. N is equal to 2, k is equal to 0 in 1. We get 1 root of this 1 raised to half is equal to, n is 2 and k is 0. So it is cos, or actually this form can also be used, cos of 0 plus I sin 0, and cos 0 is 1, so this is 1. So 1 root of 1 is unity is 1. Now put n is equal to 2 and k is equal to 1 in 1. We get 1 power half is equal to, and now it is cos, n is 2. So 2 and k is 1. So it is cos pi plus I sin pi. And we know cos pi is minus 1, sin pi is 0. So therefore this value is minus 1. And thus there are two distinct roots of unity, okay, square roots of unity, that is 1 and minus 1. So thus 1 and minus 1 square roots of unity. Unity are 1 and minus 1. Now cube root of unity. To get cube root of unity, what we have to do is put n is equal to 3 and k is equal to 0, 1, 2 successively. So putting n is equal to 3 and k is equal to 0, 1, 2 successively in 1, we get cube root of unity. And this we shall obtain one by one. First, n is equal to 3 and k is equal to 0. So put n is equal to 3, k is equal to 0 in 1. We get cube root of unity 1 power 1/3 is equal to, and you see k is 0. So it is cos 0 plus I sin 0, and that is 1. Because cos 0 is 1, sin 0 is 0. Put n is equal to 3 and k is equal to 1 in 1. What we shall get is 1 raised to 1/3, that is cube root of unity, as cos it is 2 pi by 3 plus I sin 2 pi by 3. And how to obtain cos 2 pi by 3 and sin 2 pi by 3? We shall express this as cos in terms of pi. So we have pi, and this pi minus which angle will give 2 pi by 3, and that will be pi minus 2 pi by 3. Pi minus 2 pi by 3 will be, this is take the LCM as 3, and 3 pi minus 2 pi is pi by 3. So pi minus pi by 3, we check it, is 2 pi by 3 plus I sin pi minus pi by 3. And this is by trigonometric formula. Cos pi minus pi by 3 is second quadrant, and when cos is pi plus or minus theta, ratio remains same. But in second quadrant cos is negative, so minus cos pi by 3, and in second quadrant sine is positive, and this is I sin pi by 3. Pi by 3 is the angle which is in degrees 60. So therefore cos 60 we know is minus half. This is minus, and cos 60 is half, and sin 60 is root 3 by 2. So thus this root is, we may write this as minus half, or 2 is common denominator, and minus 1 plus I root 3. This is cube root of, second cube root of unity. And for getting the third cube root of unity, we have to put k is equal to 2. So put k is equal to 2. And n is 3 in 1. 1 raised to 1/3 is equal to cos k is now 2, so 4 pi upon 3 plus I sin 4 pi divided by 3. Now 4 pi by 3 is written as pi plus pi by 3. Check it. And plus I sin pi plus pi by 3. And again by trigonometric formulae, this cos remains cos, and the quadrant is third, pi plus some angle, pi plus theta lies in third quadrant, and in third quadrant both are negative, cos and sin. So minus cos pi by 3 minus I sin pi by 3. And as in this case, what is cos pi by 3 is minus half. So this is minus cos pi by 3 is half. So with negative sign, and minus I sin pi by 3 is I root 3 by 2. And thus this root is 1 raised to 1/3 is common denominator is 2 minus 1 minus I root 3. So which is conjugate of this one. So complex roots occur in conjugates, and thus here the 3 cube root of unity are, this is first, this is second, and this one is third. Thus the 3 cube root of unity are 1, this one are 1 comma, and you see this is minus 1 plus minus I root 3 divided by 2, minus 1 plus I root 3 and divided by 2, and minus 1 minus I root 3 divided by 2. So these are the 3 roots, cube roots of unity, and these cube roots of unity may be shown in diagrammatic form as like this. So this is a circle with radius 1, and in this the root corresponding to k is equal to 0 is principal root, and here 1 is principal root. So this radius is 1, so this is principal root, and the other roots will be at a distance. See here we will have is 1 raised to 1/3 is cos 4 pi by 3, or see the first formula we have written is here, n is 3. So, or you see this will be, there will be these will be equally spaced on a vertices of a equilateral triangle, and each will make the angle 120 degree, that is 2 pi by 3. This angle will be there, and 120 degree we may see it will be approximately here, and again the third will be here. So thus this will form a triangle, equilateral triangle, or you may see 3 equal parts of this circle will be there, and not this point but this one, and thus these are the 3 roots. This is this will be equilateral triangle, and these are the roots. This is 1, then this is see minus 1 plus root 3 into I divided by 2, and this is minus 1 minus root 3 into I divided by 2, which are equally spaced on this triangle. The roots may be denoted by C0, C1, C2. So in this way we can find out nth root of unity. Some more problems on it we will solve in our next lecture. Thank you for watching the lecture.